How deep can a metal detector go? Let's dive into this. 2 years ago, I did this video, the ultimate metal detector depth test, 18 detectors versus 9.5-inch dime. Got 150,000 views. We did find differences, but the number one factor in how deep a metal detector goes is the circumference of the coil. So wait a second, Merrill, is it just that? Is it just this measurement, the longest measurement, that gets you depth on a metal detector? It's perhaps the most important factor, but look at what the XP Deus 2 13-inch coil can do.
We managed to improve the signal. Let's move down to 50 centimeters.
Um, 50 centimeters equals almost 20 inches. And that's greater than the circumference of the 13-inch coil. Well, it proves that there's more to it than just circumference of the coil. Power going into the ground is a factor. And this is a big one. Ground and calibration to ground conditions. On the Deus 2, you want to do a ground grab. You just take the pinpoint button, you hold it down, and you pump your coil, and it'll adjust to the ground. That's the calibration part, but describing the challenge of the ground gets tricky, but we're going to go there. Let's do it. How do I say this? The ground is a frickin' soup. And the type of soup in the ground is a big factor in determining metal detector depth. I have been to the top of the mountain, and I have seen the destructive force known as erosion. The wind and the water hit these rocks that are older than any coin we ever find, and eventually it breaks apart. And in short, it ends up being redistributed by nature. And the composition of our soil is not limited to the decay of rocks. Just look at this leaf decompose. But that's something that's very benign compared to this. I've noticed a big difference in possible depth in ground that contains fertilizer. Wait, are you saying cow poop is the main reason that the dirt is challenging? No, it's not all the cow's fault. Mineralization is a part of this equation. Ah, mineralization, that's a tricky one. It actually means two things. As metal detectorists, we think of mineralization as magnetism in soil. We know that rocks break down and form soil, and we know that iron is everywhere, and we know that iron is a big challenge for metal detectors. We even have mineralization measurements on our metal detectors. And this is a measurement of the magnetism of the soil that you are swinging your metal detector over. But to earth science, it's a little bit different. Soil mineralization is the process by which organic matter is broken down by microorganisms, releasing nutrients in inorganic forms that plants can readily absorb. The deepest metal detecting signals that I have ever gotten in any condition have happened at the beach. It's a ring. Okay, number one, look at that. Look at that. Okay, so beaches are the ideal setting? But how does sand get to the beach? Sand starts here and often begins its journey as part of larger rocks and minerals. Over time, natural forces like wind, rain, and temperature changes break these rocks into smaller particles, which eventually become sand. Then they get transported by rivers. Many grains of sand are carried by rivers from inland areas. As rivers flow toward the ocean, they pick up sediment, including sand, and deposit it where the river meets the sea. Merrill, where the hell are you going with this? This is about metal detector depth, right? This is a brain rot check, okay? Like, just stick with it. You will learn a lot if you stick with it. Let's keep going. Wait. So you're saying rivers carry sand to the beach? Yes, that's how the beach gets a lot of its sand. There's also decaying seashells and coral and such. but there's a process that I want to make you aware of. Look at this. This is very important. On ocean beaches, there is a process called longshore drift, where all of the light stuff gets washed away and out to the ocean. What's left is uniform particles that is free of organic material. Wait. Why again can you detect deeper at the beach? Generally speaking, the sand particles on an ocean beach are of similar size. On a rocky beach, this goes out the window. Sand has less organic material than dirt. Remember, the light stuff gets washed away through a process called longshore drift. I looked it up. Organic matter makes up just 2 to 10% of most soil's mass, and this source says 5%. But I would say that the number one reason that the beach is the ideal setting for depth is because of salinity. Electrical conductivity is a measure of a substance's ability to pass an electrical current, and salinity is the total concentration of dissolved salts in that substance. Because dissolved salts conduct electricity, electrical conductivity increases as salinity increases. I'm going to make a deal with you. We're not done. We got a lot more, but friendly reminder, please hit that subscribe button. It costs you absolutely nothing, and it helps me a lot. And 66% of the people who watch my channel are not subscribed. Goal for the end of 2025 is 75,000 subscribers. If you truly want to understand metal detecting, you need to understand the scientific principle of induction. It's how our metal detectors work. Metal detectors work using electromagnetic induction. The detector's coil generates an alternating electromagnetic field which induces electric currents or eddy currents in nearby metal objects. These currents produce their own magnetic fields, which are detected by the metal detector and signaled to the user. Pulse induction is a whole nother video. We're not going to touch it in this one. What you need to know for this, in basic layman's terms, there's energy going into the ground. There's a magnetic field going into the ground. What sends it? The transmitter coil. But wait a second, look at this. The energy that was transmitted has induced a second magnetic field. And that gets picked up by the receiver coil. And then our metal detectors go beep. And God, we love beeps. Unless if it's trash, there's a lot of trash in the ground. But treasure, we love that treasure stuff. And that leads us to, what is a metal detector's most challenging foe? Ask anybody, that would be iron. It comes in many forms and it is incredibly abundant in Earth's crust. Iron is the stuff that actually blows up stars and masks metal detecting signals. Iron is magnetic or paramagnetic. But remember what we're dealing with here. We're dealing with magnetic fields, and it wreaks havoc on magnetic fields. There's a place in the United States with notorious soil called Culpeper, Virginia. There's a lot of history down there, but look at this. The rusted soil wreaks havoc on metal detectors. It's paramagnetic, and that affects the signal strength and the depth that a metal detector can detect. So like I said earlier, the dirt soup that you are essentially detecting in plays a huge factor in how deep you could go. Despite the fine iron that is in sand, we learned before why sand is a great place to metal detect for depth. So let's flip this around and create a graphic called Piss Poor Detecting Conditions. So here's your metal detecting nightmare scenario in terms of depth. Magnetic or paramagnetic soil, high in organic content, tightly packed, non-uniform in size. All right, so here is your working nightmare scenario. A farm in Culpeper, Virginia that fertilizes its rocky and hard-packed soil. And of course, we're mentioning Culpeper because of the iron content in the soil. All right, we're about ready to drop the mic on this video, but let me clarify a few things. The deepest target that I showed you in this video is 21 to 22 inches deep, and it was in the sand. Does that mean that metal detectors, the limit to how deep they go is 21 to 22 inches? In short, hell no. Meet the Extreme Hunter Metal Detector. It's actually a coil. It's a part of the Deus 2. All I would have to do is remove this, put this here, and repair it. Not repair as in fix, but pair it again. And this is a coil, and a huge one, and it's capable of going down 16 feet. Like I said before, the biggest factor when it comes to depth, like how deep a metal detector can go, is the circumference of the coil. But there is also a relationship between coil size and objects that you can find. Oh, good old wheat pennies. You see, most people, when they detect, they like to find these individual smaller treasures, rings, coins, stuff like that. You start getting bigger than this, you're going to start losing the smaller coins. This will not pick up individual coins. It'll pick up a hoard of coins, like a big bucket of coins that were left in the ground. A lot of cannonball hunters, meteorite hunters, they buy the Extreme Hunter, and they do very well with it. This thing will get a Jeep at like 16 feet, but not an individual coin. If you make a coil that's bigger than the Extreme Hunter, you should be able to go even deeper down into the ground. But it's also going to make you size out of certain objects the bigger that the coil gets. So this last section, we're going to keep it very simple. Conductivity of metal targets and frequency used. We are in the midst of the multi-frequency age of metal detecting, and that means that the metal detector operates on multiple frequencies because different targets have different characteristics, and some frequencies are better for a certain type of target. For instance, small targets, you want high frequencies. Something that is incredibly conductive, like a big piece of silver, you would want to use lower frequencies. But a multi-frequency metal detector gives you the best of all scenarios. The most conductive metal is silver. Here's where silver falls on the conductivity chart. It's a pretty well-known fact in metal detecting that lower frequencies are ideal for highly conductive metals like silver, and lower frequencies have longer wavelengths. So now we have all of the factors listed for depth of a metal detector. So let's put together a scenario on how deep a metal detector could possibly go. Unless if you're flat Earth, you know that Earth has a molten iron core. If you are flat Earth, it's a woke molten iron pancake. Now, just for this scenario, instead of iron, let's pretend that it's silver.
You are distorting it?
Shut up, Neil. Alright, so now we have a solid silver core. Then we get rid of the iron. I hate it when they put it in my cereal anyway. This is hypothetical, but just like that, all the iron is gone from the Earth. Alright, silver core and no iron on the Earth. You follow? As for the cow poop fertilizer / organic material problem, I don't really know how to solve that. I guess the people would have to go too. I mean, we're organic material. Here's how. How do we get rid of the mountains and the rocks on Earth? Well, we just keep getting smaller and smaller with this so that we eventually get the same size particles. Everything else, the bigger stuff, we'll just shoot that out into space. So here's what's left. It is a sandy planet, and there's some salt water left because we know salt water can carry an electrical charge. It's loosely packed, no rocks left. The iron has been removed by a huge electromagnet. Now remember, there is a huge solid silver core on the inside of this planet. Now, how deep is the core of the Earth? About 3,000 to 4,000 miles. So I ran this simulation through a bad supercomputer. And this is what the results were. How deep can a metal detector go? Depth has everything to do with coil size. If you get a huge coil, what you're not going to get are the small objects. Under perfect conditions on the beach with an 11-inch coil, I got down 21, 22 inches. My record for the dirt is about 16 inches. It's a little bit more of a challenge. And it's really a question that's answered place by place. What is the amount of magnetism in the soil? What is the amount of organic material? Is there salinity in the soil or sand? What type of metal is the object that you're looking for? How conductive is that metal? What frequency are you using? Lower frequencies penetrate more. And finally, you'll go deeper with your metal detector and be happier with your life if you hit the subscribe button and the like button. Hope you learned something. Thanks for watching.